using the specific heat capacity equation to calculate a brake's temperature rise by KayScience.com. This is the problem you will learn how to solve. Press pause to attempt it. The method and the answer will follow. This here is a car, and these are the brakes on the wheels. The car has a mass of 1,000 kilograms, and it's travelling at a speed of 20 meters per second. So using this information, we can calculate the energy stored in the kinetic energy stores of the car as it's moving. To equal the equation, kinetic energy stored in an object equals 0.5 times mass times speed squared. So you substitute in the numbers, kinetic energy equals 0.5 times 1,000 kilograms times 20 squared. So the energy stored in the kinetic store of the car is 200,000 joules of energy. 200,000 joules of energy is stored in the kinetic energy store of the car. So to go from 20 meters per second to 0 meters per second, the car must transfer the 20,000 joules of energy stored in the kinetic energy store of the car to the brakes. So to come to a stop, the car must transfer 200,000 joules of energy from its kinetic energy store to the thermal energy store of the brakes. So when the car applies its brakes, energy will be transferred to the brakes, and there's going to be an increase in temperature of the brakes due to the energy being transferred into the brakes' thermal energy stores. So what we're going to do now is use the specific heat capacity of the brakes, the mass of the brakes, to calculate the temperature change of the brakes. So the specific heat capacity of the brakes are 400 joules per kilogram per degree Celsius, and the mass of the brakes are 20 kilograms. So assuming no energy is transferred and lost to the surroundings, and all of the kinetic energy is transferred to the thermal energy store of the brakes, we can work out the temperature change. And remember, 200,000 joules of energy is going to be transferred into the thermal energy store of the brakes. So we know that delta E, the energy transferred, is 200,000 joules. So to work out the change in temperature, we firstly need to recall the formula. Energy transferred equals mass times specific heat capacity times the change in temperature. And we need to rearrange the formula for the change in temperature, delta theta. So the change in temperature equals the energy transferred into the object divided by mass times specific heat capacity. So let's now substitute in the numbers. 200,000 joules transferred into the brakes from the kinetic store of the car divided by the mass of the brakes, 20 kilograms, times by the specific heat capacity of the brakes, which is 400 joules per kilogram per degree Celsius. That gives you a temperature change of 25 degrees Celsius. So the brakes will have increased by 25 degrees Celsius because energy has been transferred into the thermal energy store of the car's brakes.
It's question time. Attempt these questions to check your understanding.
This is the problem you will learn how to solve. Press pause to attempt it. The method and the answer will follow. So this car has a mass of 2,000 kilograms, and it's travelling at a speed of 40 meters per second. So to calculate the kinetic energy stored in the car as it's moving, you equal the equation kinetic energy equals half times mass times speed squared. You then substitute in the numbers, kinetic energy equals half times 2,000 kilograms times 40 squared. And that gives you kinetic energy stored in the car of 1,600,000 joules of energy. So for the car to come to a standstill, that 1,600,000 joules of kinetic energy stored in the car must be transferred to the brakes. So to decelerate from 40 meters per second to 0 meters per second, the kinetic energy stored in the car must be transferred to the thermal energy stores of the brakes. So 1,600,000 joules of energy must be transferred to the thermal energy store of the brakes. So the specific heat capacity of these brakes are 475 joules per kilogram per degree Celsius. The mass of the brakes are 30 kilograms. The energy transferred into the combined mass of the brakes is 1,600,000 joules of energy. So what's the temperature change going to be of the brakes? We recall the equation: energy transferred into the brakes equals mass times specific heat capacity times change in temperature. We need to rearrange for the change in temperature. So change in temperature equals the energy transferred divided by mass times specific heat capacity. So now substitute in the numbers: 1,600,000 joules divided by 30 kilograms times by the specific heat capacity, 475 joules per kilogram per degree Celsius. That gives you a temperature change of 112.3 degrees Celsius. 112.3 degrees Celsius. This is assuming all of the energy is transferred from the kinetic store of the car to the thermal energy store of the brakes. In reality, that doesn't happen because the energy is also being dissipated into the thermal energy store of the surroundings.
It's question time. Attempt these questions to check your understanding. Press pause to practice using those key words. The answers will follow. Press pause to go through your answers and make any corrections to your mistakes. Press pause to answer the questions. The answers will follow. And if you're stuck, just re-watch the video. Press pause to go through your answers and make any corrections to your mistakes. Visit KayScience.com for more free videos, worksheets and quizzes at KayScience.com. And don't forget to like and subscribe.